click on go live. Okay. Okay, then I will show. So hello everyone. Welcome to today's webinar about building MLOps pipeline. And during this talk, I will mainly the main intervenant will be René and Eric, which will talk about their practical experience and good practices about how to build a complete machine learning operational pipelines to reach your objective based on their experiences in industry. So I think it's best to wait for a few minutes so that well, people can arrive and well, just to that everyone can well, have some. You can also interact during this session. Do not hesitate to be interactive in the chat, and we'll try to answer your question either through LinkedIn or YouTube. And then after this few waiting, I will let René and Eric to present the subject. So for myself, I'm a part of the, so René and Eric are intervenant not from the data scientist team, but I myself, I'm a data scientist at Data Scientist, and I will try also to answer your question in the chat, either through both of them, LinkedIn and YouTube. So the presentation will, the time will be about 1 hour, but if you, I think that will be also a dedicated time at the end of the presentation for well, asking a question. But once again, you can ask them anytime you want. Okay, so good morning also to you, Kambo. Okay, I will also. Okay, so for now, we only there are only me, Robin, and René, but Eric, the other intervenants, will come soon. Do not worry about that. Okay, so I'll also read the chat. Okay, so you can also present yourself in the chat like Combo. Okay, so that's it for me. So I think the presentation will begin by an introduction of both Eric and René, and then I will let them present their slides and their experience. Any document for me on the session, please? Okay. So okay, I do not quite understand your question, Marshall, but
I think to provide some information, we can share probably the slides and additional information. Probably you can also link them to be data scientists, like trainings. I think to
yes.
be data scientists, you need Python courses, for example, data science courses with machine learning. I think all this topic to provide to him.
Okay, so that's a good answer. Okay, so well, feel free to ask for bonjour, hello Bernard, sorry for the French word. But Combo, if you want to ask any more information, I can provide you with some links through the chat.
Yeah.
Okay, we also check for LinkedIn. Okay, so we have both well, both channels are on. Okay, so well, if Eric is not coming soon, I think René, you can begin by introducing yourself. And once
Yes.
again, I will also remember that today's topic will be about to well, how to build machine learning MLOps projects from the beginning through pipelines, and also the main feature here will be the practical experience from René and Eric. So Eric is back. Sorry for the little waiting, but now you can introduce both of you and begin the presentation.
All right, so thanks, Robin, for the introduction. Hello, everybody that you joined this stream, this webinar. I'm really happy to show you our presentation. We will present the complete MLOps pipeline and practical experience which we gain. So we set up this pipeline or have experience from Vodafone, Telefonica, Bosch, Siemens Hausgeräte, and we want to share with you what we learned from these lessons, because it's not only just to deploy a model in Kaggle if you want to be a data scientist. So everybody's talking about cool model, fancy building, and then to win the Kaggle competition, but it's not all. So often beginners, when they start in companies, they get often frustrated because the data is not there, or they have problems. It's not only about this predefined data, but rather to bring the model in the market and deploy it very fast. So time is here really critical also for the companies, for enterprises, to bring it in the market and also to keep it updated. And about this we will talk today. As mentioned, we plan around 40 minutes of presentation. You can put your comments or your questions in the commentary field, and we can answer them directly. Also, at the end, you will have time to have the discussion about our topic. That's from the general part. So we are two speakers. I need to apologize a little bit. We uploaded the slides like a PowerPoint format, but somehow it's squeezing a little bit in some points. About me, I'm a professor at the Macromedia University. It's applied university in Munich. It belongs to the Galileo Group. Galileo Group is French private sector. I think it's the second biggest in the world. And also half-time, I'm working at the consulting company at Datamix GmbH, and we provide to customers, to normally big companies, the MLOps pipeline. And yeah, then I hand over to Eric to present himself.
Hello, I'm Eric, and also a warm welcome from my side. I currently work at BSH Home Appliances as a lead architect and advisor for all topics AI, and also as a lecturer at Macromedia Hochschule. Yeah, and we want to show you the concept and also the practical experiences of our MLOps pipeline that we have built now in several projects. So it has been an evolutionary process over several years now. But before we go into the details, into the technical details, we first want to answer several other questions. So could you go to the next slide, please? Yeah, because one of the most important questions if you talk about MLOps is why do we do MLOps, and what is the purpose of it or the benefit, and why do we need it all, and what is it? And to answer that question, you actually want to go, or might want to go back several decades in time and answer another question, which is essentially the prerequisite for MLOps, which is about what is DevOps, and why is it omnipresent in software development, because this is the foundation essentially of MLOps.
There's also a question about, would you please explain me the difference between software engineering and data science? This is a very good question, because we go in there. So now we have data science. You analyze something, you make a cool algorithm to optimize your company, to create a business value, and more analytics. And engineering, you build maybe some web page with the backend, so really software architecture. And this MLOps, it's coming from the DevOps part, software engineering, and now we bring in all these tools and experiences to the data science world. And this we will present. So Achim, you can also put the next slide. You have the feature?
No, I don't have it.
Okay.
So
I will move it.
Yeah, this is already going in the direction of the answer of this question, because underlying below MLOps, you have DevOps, which is traditional software development. And from the experience people gained over decades in developing reliable software with reproducible behavior, some mechanisms have been evolved to automate this process, which is called DevOps. And these mechanisms are now getting extended to also put machine learning on top of the software that is underlying. And this is what is called MLOps in short. That's what we talk about. So if you go back to DevOps, and why this is omnipresent is you have essentially 3 stages. First, you have the continuous integration. This is mainly about teamwork. If you work together as a team, you want to know where the current version of a code is. For example, if somebody gets ill or is on holiday, you always want to have this reproducibility where you as a team know what is the current status of the software you are working on, what is the current status that is in production. And therefore, this is called continuous integration. Whenever someone is in the team is creating code, it's put into this repository and everybody else can access it and knows what is the current status. And then you go to the next stage, continuous deployment, where you automate the process of the preparation of your code before it gets into production. So you create some tests there that are being run automatically. You could also consider them as quality gateways, where you have something like a baseline that you know that the code more or less behaves as expected before you put it in production. So yeah, and then the last stage is then after you've checked your code and you have the impression that it's good enough to put a new version into production, then this gets handed over to the running infrastructure, where you put some monitoring on top of it to continuously check is the performance well enough. For example, the answer times of a web page, are the servers not overloaded, is the infrastructure running at all? So this is more going in the direction of robustness and having the infrastructure status. And now looking at these 3 stages, the experience that has been made in software engineering over decades, we now try to extend this to to machine learning use cases where you have software plus machine learning models. So I would argue it's just an extension of DevOps, where again you have the same 3 stages, but now you have 3 artifacts. So in software development, you just version the code. If you have a machine learning use case, you again have the software as a wrapper around your model if you want to run it in production. But in addition to the version code, you also have to version your model, because you have several training cycles in your model. And again, you want this reproducibility. You want to know which version of the model that has been trained with a certain kind of data or with a certain algorithm has been used. All this bookkeeping is also part of, or should also be part of this pipeline. And therefore, you have to version a model. And ideally also you version the data so that you have, with which snapshot of the data the model has been trained. This is again for reproducibility. If you want to find errors in the behavior of your model, you want to go back and check what were the circumstances under which this model has been trained. And again, the second stage, where you have the continuous deployment, is analog to DevOps. You run automated tests, but in this case, they are extended to testing the model, so not only testing the code. You probably know for certain edge cases already how the model should behave or what it should predict these edge cases you can use to create these automated tests and test if at least in these well-known cases for you, the model behaves as expected. And then again, the third stage is running the model. It's similar to DevOps again. You have the traditional monitoring for your code and your infrastructure, and now you also model the behavior of the model. You might have heard about the model degradation or concept drift or data drift that can happen over time if the environment changes and does no longer reflect or the distributions of the data, for example, might have changed if you compare it to the distribution of the data that has been used to train the model, and therefore the predictions over time get worse. Yeah, and now we can talk about the pipeline itself. Now you could ask yourself, yeah, why don't we just buy one of those out-of-the-box platforms? There are a huge amount of open source projects now. Could be quite easy, but we decided not to do that, and for certain reasons, because we made some bad experiences with these out-of-the-box tools. One of the reasons is for most of the big companies, especially or even more so for BSH, we have lots of heterogeneous use cases. So we have slow and fast moving data. We have images and natural language processing, sensor data from IoT, from customer IoT, from industrial IoT. So we needed a really flexible and versatile and also modular end-to-end blueprint to build those end-to-end pipelines for certain classes of use cases. Therefore, we didn't find anything out of the box. This was one of the main reasons. Other reasons are handling the complexity in a large corporation. You have many code versions. In the beginning, we had on Lost Jupyter notebooks. Also, the governance issues. You have hundreds of functional users for the scripts that create the infrastructure or that deploy models in production. And often those platforms you can buy out of the box, they don't offer this so that it really connects seamlessly with the infrastructure of a large corporation. Also, data science has a high employee fluctuation. So the ready-made platforms, they really didn't cut it. Another big problem we had is that they are often black boxes. So as long as you work within the constraints of such a platform, it's all nice. But as soon as you get to the limits where the platform doesn't offer a certain function you need, this black box approach can become a big problem, because then you run into a brick wall and you can no longer extend it. And essentially you have to restart from scratch. And this is something we wanted to avoid. So we chose a modular approach where we use open source as much as possible, but only on a modular level. And then we create the glue code and the orchestration on our own. That's something that René will show you in more detail now. So that we have a really flexible architecture that can be extended arbitrarily on the go. Also, we can replace older modules with newer ones. Okay, I think now we can go into the details of the pipeline. And I want to hand over to René here.
Yeah, thanks, Achim, for the introduction. So maybe to recap what we did. So first we showed why you need MLOps and the history in DevOps, what is taken over, that you have a background understanding. Then we showed why it's important. So the big solution, maybe a cloud vendor, that you put everything in there, you have everything on it, but then you're also limited and you cannot move forward. There are some features that are not available, maybe they're older. That's why we moved in with different components, which I will show at the next slide. That's really how you can do it, how you can build this pipeline. maybe some question or maybe a question for you if you have some questions in before we start with the next chapter, or is it clear so far? All right, then let's start with the MLOps pipeline. Maybe a question to the audience. Maybe you can also put it to the comment. Whom of you heard already about MLOps or is using it? Clear so far. Who's using MLOps? Thanks for your feedback. So I assume no response is that nobody's deeply in there in MLOps. So I think it's great that we can show it to you, because also often when we come to companies and also now from the students, they're coming many who know to train models. They have Kaggle or Clean Data University. There are many data scientists in the market, but then to really roll out this model, how to put it in production, how to rebuild the model, what to do if there's a data drift, if something changing in the model, if the environment, there is, I think, a big gap. And now we show you how to do and what to consider in the background, how to automate your deployment process. So therefore, we made these categories and different stages. We have it separated in, let's say, 5 bigger stages. First, if you have a data science project, you need the data. I think this is biggest deception often when you start a data science project, that you don't get the data is not clean, that it's broken, it's not feasible or technical, or not allowed with the data privacy and so on. So first you need the data ingestion, then you need the data preparation. So if the data is not clean, you need to prepare it to clean it up. And then you have the model training, that you say, okay, now I have my data and I want a perfect model to predict the future. And then you need first to test your model with real data. You have to roll it out to deploy. In some companies or in many companies, you have maybe thousands of users, and still you have to really, to deploy it, that it's available and also that it can run over there. And also then running, you need secure, safe infrastructure, which also has a high availability. These are the pipeline, and around the pipeline we have process management, process which support these stages. And what is also a topic, most data scientists or many data scientists don't like or don't do or don't know, is the governance, which is really important. Otherwise, you get huge problems. You accumulate your mess and then get problems in the future. And we go through now each of these steps, what to do in each of them. So we start first with the process management, because often if you're in a company, you want to start to work, then maybe there are firewalls, you don't have a GPU instance, there's some stuff missing. And then you need first, call it a data science workplace. It's an instance where you have all your tools and can do your work. Then you need also job orchestration, loading data, going to one step to another step. If you have this pipeline to tell, okay, now execute this, you have this debugging tools, and therefore you need a job orchestration. We did this with Apache Airflow. If you maybe heard about it, you can then schedule your jobs. And you also have acyclic graph, that you have dependencies. You need to wait for one job maybe until you can only do the model training when the data is ingested or when it's prepared. If there's no data missing, then you can define all your dependencies in Apache Airflow. Then we built generic helper libraries also, we call it in the process management, because if you need to read data from Azure Blob or from AWS S3, and you do need to do this often, these processes, or you need to add keys. So all the standard processes, which a lot of people need to do, we put it to one generic Python library, and then everybody can install it and reuse it. When we started this building 4 or 5 years ago, I think it was quite new. Now there's a cool tool which is called AWS Wrangler. If you use, for example, AWS, but there are also other tools out there which are growing. This is just one hint. And explorative data analysis you need to do. If you're a data scientist, you cannot roll out your model first. You have to check your data and everything. And therefore, you have here Jupyter notebooks. It's the standard, let's say, for this explorative analysis. You want to see the data. How is it structured? How you can use it. And then also run your preliminary experiments also there in your workplace before you start then the real rollout. So this we cluster to the process management. And then we go through. Here on the top, you see which stage we are. Now we start then with the first stage on the left. And here's the ingest. You have different types if you want to get data. I think most common is batch processes that you just load data once per day. But in the future, the companies should get more into streaming, that everything, or the leading companies, they use streaming now, that all data is streamed directly to your environment and then analyzed directly. Your model is retrained, prediction is done on the streaming process, that you don't execute it maybe once per month, or maybe even, data science projects, they execute it maybe once per year, it's trained, but here it's really then data is incoming and then you need to train it and process it. Then you have to consider about storage, how big your storage needs to be. Do you need an archive? How long do you need to store your data? What is the availability in this storage type? Also, if you use databases or if you just use data store, I think here you have a lot of open space, let's say. A standard is like storing a CSV file or a JSON file just on disk and then process it. But there are time series databases, graph databases, then faster databases, you have JSON databases, so different kinds of all databases. But I think it's good to start with a simple disk space and then analyze there. Also, what you need to do is the basic quality checks, because always, I think this is really crucial for your data science projects, what people always, or often, not always, often underestimate. If you have garbage in, it's like you get the garbage, your data is not good, it's the garbage, then you cannot get good results at the end. And people often, they try to squeeze your model training, or you have a grid search and want to optimize 1% or 0.5% of your model. But if the data which is incoming is not good, your model cannot be good as well. So you should really focus then also on the quality. And here's some basic checks. Also, some storage optimization for faster queries here. If you don't only store it on some disk, but you can use some conversion, compressions, different databases if you really need then this faster queries. And what you also need to consider before you load it to your data lake or to your tool system, that you anonymize or pseudonymize your data, to talk to the data privacy department, and do this then outside of your component. So while you're ingesting the data to your system, then also to anonymize it and pseudonymize. This is especially important if you have personal data. Then we have a next stage, the preparation stage. And there you have to impute your data, for example. You need to transform it if the format is not perfect. If you have JSON files and you need some different format, a tabular format, then you can use it here. For heavy transformations, you can use Spark jobs. If you have a lot of data, If you have smaller, then also different jobs. You can do it in Apache Airflow with smaller points. In AWS Lambda function, you can have a server. I think there are many options. Then you need also the feature engineering, exploring which features are important, which you need, which you can take. And here in the preparation, you go next level for the quality checks, because at the beginning you can only see if data is missing, maybe, but you cannot dive into quality if there's a drift or if there's wrong formatted data. So here, then you go really in the project specific quality checks. You do data enrichment. And also what is important is labeling. I think there's, like in data science, there's this supervised and unsupervised machine learning models. Easiest one is unsupervised because you just run your model, but it's all less the case that these are really good. More performant are often the supervised, that you label something. If you have images where you want to detect if a cat is inside, and you need maybe 100 images, and you have to manually select, okay, in this image it's a cat, and this is not a cat, and then to do this labeling. And there are also different tools out there. It's Labelbox or 551. I don't remember. It's also a tool. So they're out there, and Labeling Studio, they really provide you then this service. You see the images, you can label, you can add the external labelers. You probably don't label everything by yourself. If you have millions of images to label, then you can outsource this, and then you have specific tools which can do this labeling. Also relabeling, checking quality of the labels, and so on. And yeah, this is the preparation phase. So we had ingest, now the preparation, and afterwards we go to the training stage. Here it's going out about, yeah, of course, you train your model, you select the best model, you make, for example, a grid search and so on. And if you're now on image processing or an NLP, ChatGPT, and so on, text processing, then we're going also in the direction of GPU. So you have to consider for your trainings, is a CPU instance enough or not? If it's GPU, then you need a cluster or even the TPUs. And also to consider your algorithm, you have challenges. If you have a big GPU with 8 cores, you also need to code your program to use these 8 cores, which is not so easy. Then you're getting here this challenges. Or also if you set up a complete cluster, you need to distribute. I think this is quite tricky. But anyhow, if you have one GPU, also to consider the costs, the shutdown mechanism in your pipeline, that you not leave it running. If you have an AWS GPU clusters, which costs up to 40,000 euros per month. So then you have really to optimize your model training, so shut it down to have your pipeline over there. And what is really important is then experiment tracking, because if you train a model and you're sitting there, let's say 2 years training your models in your Jupyter notebook, then after 2 years, you don't know which model you trained, which input parameters, and many things. So if you trained it already, can you tell me now which model you trained 2 years ago? Probably you cannot in 5 minutes, because you need to look up everything. And with MLflow, you see then it's a management tool. You see all your experiments which you had in the past, which you have been executed. You see the performance between each model. You can select the best model. You can deploy the model. You also have model versioning. If you retrain it, you can put it into production, the model. You can remove it from production. You can put it to the archive. So all your model management is done with the experimental tracking. There are many tools or different tools. We used MLflow. It's open source tool, and quite nice. That's why it's one of our central components to track this. It's also cool if you just do some data science. Also there you can use it, that you have tracked all your past. If you do your master thesis, PhD thesis, I think, to track all your experiments, you can also use it. This is about the training. phase. Then we come over. Once you trained your model, now you have your perfect model with a 99% accuracy. And then the next step is to deploy it. And it doesn't stop there. I think often in university or courses, it stops maybe at this point because you don't put it in production, but then it's also some different parts over there. First, you need some blue-green deployment or some testing staging system. If your model is ready, you cannot just roll it out. You first maybe to test it with some users, maybe 100 users to check the predictions. And if this is fine and working, then you can roll it out to all. So you have to have this smart testing. And if you want to roll out, also imagine the models, you don't train it once per month. You really maybe train it once per day. Because it might be, imagine there was COVID and you are online shop and need to make recommendations to users. And then from one day to another, there was a lockdown or the behavior changed completely. Then also your model need to change. So you cannot make the old recommendation. Maybe you have now to recommend mask or something else. So you really have to react fast to the environmental changes. And therefore you need also to deploy fast. And if you need to do manual tests, then you cannot deploy your model every day because then you're just testing. So you need to automate testing, blue-green deployment, first usage for some users. Then you have this automated retraining because I also have seen that data scientists, they log in every morning, check the dashboards. Here's a model. I need to retrain, check data. This you can also automate the retraining that you just evaluate later the performance. So every day you retrain your model, check if it's better or worse than your existing model. And then you can, with one click, you can deploy it over there and can say, okay, let's roll it live. You also have some, I will show in the next slide about the monitoring, that you also can get notifications once there is a better model than on Slack or on some communication tool. You get a message, oh, your model, you have a new one, and you can deploy it. You log in, check, okay, it's fine, then click and new model. And that's your life then of a data scientist. If you have everything automated, then it can be just clicking and checking your system. Then you have also quality, security testing, gateway. If you deploy it, that you have all the keys, API keys, which is also often maybe not considered. If you have some API proposed to the internet where you can send predictions, then also you need there some security, user login, API key authentication, and not to forget this, because I think also nowadays I have seen a lot of hackings that companies have been hacked, to take care about these aspects. And another nice feature is the model compilation. And this means if you go for hardware devices, so if you go to the cloud, probably you have a big instance. It's maybe cost intensive, but it's quite easy to start a huge AWS, Azure instance and then make your deployment. But if you also think that maybe you have a small machine or Raspberry Pi, a fridge, or different device, then you don't have a big disk and you don't have much CPU storage. And there you can then compile a model. It's like compressing a file. If you have a text file and you zip, then you see it's smaller. And the same you can do with models. And there's also a trade-off to find if the compression is reducing the quality of the prediction. Maybe you can do it. So it's also a complete topic then to consider if you go to these directions. And what's really cool is Docker. I really like it. It's also coming from DevOps environment, and we can reuse it in the data science environment. You just put everything in a Docker container, for example, and you can roll it out to AWS cloud. You can roll it out to Azure cloud. Also, if it's running on AWS, and then you think maybe in 2 years, oh, I don't like AWS, whatever, then you move the Docker container to Azure. So there are little constraints, but it's much easier than you deploy it locally. So this Docker containerization with Docker, it's really cool because you can also test it first in the same environment and then roll it out over there. So you have then this target specific deployments, staging system, prod system, on different underlying hardware. You can roll it to a Kubernetes cluster on demand. You put everything. Also, what's cool then with this, that the data scientists, if you have this in a Docker container, they are free. Whatever they do in their environment, let's say, put it in there, and then you can ship it everywhere for the deployment. And last phase is then the run and serve. Here you need infrastructure and software monitoring. We have two different monitorings. One is the infrastructure. If the server is down, you need to restart it. Maybe if you need the prediction, if no data is incoming from the ingest, you need to count if there's a problem. So all infrastructure problems you need really to monitor. This is the first step. And then the second one is the model monitoring to check the performance of the model. If you trained it, it's 99 and maybe it's decreasing to 80, and then there's something wrong and you need to act really, really fast. And it can be also the data drift, like with this new environment is incoming, like COVID, for example, and then changing from one day to another the environment, and you need to, or the data is then changing, then you need also to retrain your model. Also, then you could create a generic API for inception. This means that you have some client sending some message to your server, prediction. He wants to know if a review is positive or negative, for example, some text or some image. Is a cat inside? Return yes or no. It's no cat inside. Then you need this generic API. There are also different services. There's Selton, which can do this deployment and serving, but there's also MLflow. It provides an API for this request. And you have a high availability you have to ensure, because if you have a tool which makes predictions for an online shop and your service is not available, you have fallback, but you lose money then if you don't make these predictions, because from what I heard from companies, they make up to 40%. I think also Netflix, 40% of the revenue is based on recommendations. And if your recommendation engine is not running, then it's really a lot of money, or the people are unsatisfied and will complain. So it's really crucial to provide this high availability. Then we had a question about the uses of CPU. And yes, we have different possibilities. If you train a model, if you have a sklearn model, a simple one, or linear regression, or k-means clustering, then you can do this on a normal CPU. If you want to go to deep learning, like ChatGPT, BERT models for natural language processing, like with TensorFlow or PyTorch, then you need GPUs. It's this graphical chips, and these are more expensive, but they are also much faster if you use a GPU. All right, and then we have this underlying layer of the data governance. And here we have the topics, which are often forgotten. Also, if you're for beginner, it's not so important. And if you're like data scientist, normally you're stressed to find good models, good quality to make cool predictions. But yeah, then you need to consider security. So if it's not hacked, if it's not falsified, to make it really secure, and consider this already in your conceptual phase of your project. Then the user management. If you have big projects like the central data lakes, there are hundreds of users on it, and you really need to keep track of it, to clean it up, to see who has access to what, make it fine granular, and this is really time consuming. If you don't do it, the mess to clean up, it's really difficult. So define it at the beginning, use a consistent user management concept. Then you have the data governance part, also with the user management, with the security concepts, which is going there. I think a good approach is to do a task force, which is going there maybe every week or is meeting once per month, and then to discussing all this topic which arises to face it directly, security updates, cleanup of your data, of your data lake. And also trends going from, let's say, data governance in the direction of data mesh. Maybe you heard it, or data fabric. It means that before you had everything centralized, because the advantage of a centralized system is that you have all the data. Maybe you have a different department, you have the marketing department, which can combine the sales maybe with the production and make some correlations and find out all these customers that need a different setting and so on. So you can make really cool or more data science cases if you centralize, if you have more data to combine. But the disadvantage is you have at some point it gets like a big mesh, a big mess. And the idea is then, like, if you have a big lake, where you can swim, or and then you have this. Well, I don't know. It's in English. The guy who was telling what you can do, what you're allowed to do and not to do. And the idea is then to make a little lake, and you can do whatever you want. And you have a small pipe between the big lake, which has the big rules, and you cannot do everything. But in your small lake, you can do whatever you want, and you put your data in there. You have a loose connection. Also, you can call it something like a satellite approach. And then people are also more happy because you can maybe reduce the constraints. And what you also need is the data, that you know which data is where, and this is called a data catalog, that you can see this department has this and this data, or you look for data, I need email addresses, or you need from this machine, and then in this big search catalog, you can look for data which is there, which I can use for my cases. Who is the responsible to contact? So it's structuring your data and get an overview. And the last one is data privacy. Always to be aware that how long you can save data. Go with your data privacy department. If you're like stock companies, they might keep data 15 years and then they have to delete it. Or some others, they have private data you're not allowed to share. So it's also a big topic, how long you can store the data. Are you allowed to store it? You need to anonymize it, pseudonymize it, what you can do there. And normally there's a data privacy department to reach out and work together with them, also with the security department, and not to do everything by yourself, to get feedback from them that you get then safe systems. Yeah, and this is then the conceptual pipeline which we used on high-level pictures with the different stages over there. All right, and this is about the pipeline, and now we're coming to the end. I don't know, Achim, do you want to take over, or should I finish it?
Or you can go on if you want.
All right.
Mm.
So what can we take away out of this? So our experiences from many years of building these pipelines, automating machine learning tools, data pipelines, is that first to understand the current demands. So not build something fancy in a concept, but find some real concrete use cases where if your customer who has a business problem and you as data scientist can solve it, or you as a data engineer, if data scientists come to you and they need something over there to help them. And then if you get two data engineers maybe, or two business problems with the same, then you can think about to generalize it, because if you have maybe one connector which is used 9 times, then it makes more sense to build a central, maintain it once, keep it there. So first to build really what is needed, and then second step to centralize it. Then the flexibility to replace components of the pipelines. We have seen that tools, they evolve and they scope quickly. I think I'm 10 years around in a big data environment or more. There were tools like Hadoop. It's now fading away. You have it, but it's not managed anymore. Before were big clusters and many companies, and then after 2-3 years they descoped. They haven't been there anymore, and that's why we want this flexibility to say, okay, we have these components which you have seen, and if there's a better tool which is really really fast in development right now, then we say, okay, we squeeze out one tool and plug in the better tool. That's also why we didn't want this big vendor, because then you're locked in. They're always or cloud system, AWS, Azure, they use open source software maybe, or they're a little bit behind the small companies. They are often faster to provide features. Then also fail early, fast, always start with a small POC and then grow continuously, look where's optimization potential, then optimize, and then grow on. Look for these generic solutions, then specific use case. If you build up only one use case, and then you can end up in some island and building only for one customer. But if you're in a company and you want to automate your data science use cases, if you're in a MLOps environment, then you shouldn't do one specific, but you should build some generic solution which can be rolled out to all the company, that all use cases benefit from your settings. And also you need to reserve this time for data governance to really say, okay, once per week, once per month, we sit together, we discuss what to do, and then also reserve maybe 1 day per month to do then the operations, or depends how big your project is. Maybe you have one person just dedicated for data governance. Then also some pitfalls, what to avoid. This technology islands to reach a quick win. Maybe some department or some data scientist businesses say, oh, I have this tool, we have to quickly install it, but then you're locked in some tool, and if you don't see the big picture, then it's hard to go out maybe. So not to go to the quick wins. Of course, you have to go to one project, but then also to see, okay, are there different projects, they have the same problem? And if yes, we put together, we put the budget together, we put our energy together, our capacity, and then we build it for everybody. And then also these tools, as you have seen, we have not one big vendor, we have a lot of small tools, but the new tools coming, it's really time consuming and also often expensive. That's why it's important to do it in a well-structured way, maybe also to reach out to others to see how they did it, do some demo cases, but there's really large number of tools out there. And also to avoid the vendor logins, that you don't get logged in, you cannot move away, because there are more tools racing and upcoming. So check that you're independent. One example is the Docker container. You can put it in a Docker container, and then you can roll it out to Azure Cloud, to AWS Cloud, to your on-premise Kubernetes cluster. Then you're not logged in one cloud. There's always some login mechanism, but at least you have the chance to move to some other tool. And also then to check end-to-end perspective of your pipeline, what you have seen now from the beginning, data ingest to the rollout, not just to deploy a model. Also not just this train and run away. Like to train a model, you have 99% accuracy, and then you go away and roll it out. Some companies also do this, but then it's only the first part, maybe the smallest, but then you really need to follow up, monitor, how is the data, how is it going on with the environment. Yeah, that's it from the pipeline. I hope you learned something new. We first discussed a little bit DevOps, from where MLOps is coming, why it's important. Then we gave you this pipeline, and it was built up in different companies, which we're setting up together with Eric. And this have been our experiences, how it is now from some years of building this pipelines, and then also our advices at the end, which you would give to you.
Okay, thank you to both of you, Eric and René. So, well, you did a little bit more than 40 minutes, but that's okay. Well, concerning the question part, I do not see any question in the chat, but I have some question for myself. So if you want, I can ask them to both of you, if that's okay. So,
Sure.
uh, okay. So when you talk about the feature engineering part, do you recommend using like AutoML libraries like Picaret, Lazy Predict, and things like that, or is it just for the exploration phase and not for the production one?
What do you mean exactly with the bots? Can you explain it a little bit more, please?
Because when you're building pipelines, so you talk about the feature engineering, which is
Yeah.
an important part about building a machine learning model. But do you recommend using AutoML libraries, which do the feature engineering job at your place? So is it a good practice, or is it just for exploration phase or fun, and not really a good practice in production?
I think it's a good part to use the AutoML tools. We also use some, and then also to check which is the best, especially for exploration. You need the feature engineering. For the production, you have normally the monitoring tools, which are more important. And inside of the monitoring tools, you have also this data drift. And the data drift tools, they're also checking your data, if they're moving, if the numbers are falling down suddenly, and then you get also this alert. So I think they would put more effort to this model monitoring tools. There are also tools that include this already in the pipeline. We have a separated tool to do there. So I think there are these different topics, but it's really important to monitor the data and if the features are dropping or changing.
Okay, thank you for that answer. And then concerning MLflow, which is a good, I think, tool or framework for deploying and automating the versioning of the model. So we can see the documentation that we can store the artifacts of a model, so some version of a model with not just a pickle file, but also some kind of environment variable setup, storage database or on the cloud, like S3 buckets. But in practice, what do you recommend for storing these artifacts to be efficient?
Yes, we add with MLflow the artifact. So what you also need to do is maybe, especially in Europe, there's this new law they're discussing about the fact that you need to store the data and the model version, the code, so everything with which the model was trained, you have to store this information that you can say, okay, this model is predicting this because it's based on that information. Of course, there's some randomness in there, but you need the data version and so on. So you can use a data versioning system, or like you mentioned, you could put this data as an artifact, put all the other artifacts which was trained, whatever you have. And then with MLflow, you can store it to S3 or you can store it to Azure Blob, and then it's connected with MLflow. The code, you have integration with Bitbucket that you can see directly MLflow, this model, you click on it and then you see it was trained with this code, or you can put some link with which data it was trained also in there. So we work with this artifacts to put it next to the model, and then it's uploaded to the cloud. You know the ID, you can retrieve then all the artifacts.
Okay, that was clear for me. And I think, when the chat, do not hesitate to add detail or to ask also some question. And then at the end of the presentation, you talk about data governance. So maybe it has a trouble of connection. I do not know if you answer the beginning of my question or are there any noises or disturbances? Okay, but for the data governance part, so who's really in charge, and is it more a technical role or more like a strategical one? So what are the competency for having a good data governance?
It's a different part. So sorry, sometimes connection is interrupted if I don't get everything. The good part is who's involved. It's not only one person. Also, we tried it also one person, but it's just it's not possible to do. First, it's not the most fun part. You have to find a person which is fun, only just to clean up users. So it's a team of persons. So normally it's the let's say the lead of the department of data engineers or the data scientists. So it has to be management involved to make fast decisions. And then you have operations there, the admins, which are really on low-level infrastructure, who can give rights, who can set up servers, tags, cloud engineers. If you're in the cloud, these you need to be involved. You have senior data scientists, so it's really a larger group. And also you need from security some responsible always in the calls in this round, because you have always questions, or you can say no, you cannot do it like this, to get also fast decisions from them. So it's a big team, and everybody has to contribute. Also, everybody has to be aware. So this is also important, that because if you have only one person and everybody is making let's say the mess, and you just behind cleaning up, it makes no sense. So everybody has to know, okay, their part, and if they create mess, they have also the problems, they're also involved. It's their part, and they cannot give it to somebody else. That's a very good question.
And it's also not only technical roles. It's above that you also have the business rules. Yeah, that business tells you, okay, this is highly confidential financial data that that almost no one should see, and therefore they also put some constraints on how the governance will look like. So essentially, they create the rules, and then it gets implemented on several technical levels. Yeah. Building the user rules and the rules for the scripts for the automation also.
Okay. Thank you for both of your details about that. I will also thank you once again for presenting today the machine learning operational pipeline, which and also about your experiences. So we last about 1 hour as promised. And also I will remember to those who are watching this video later on or in live, to subscribe to our YouTube channel, and also subscribe to the newsletter of webinars and data conferences, to not miss the following one with good intervenants like Eric and René, which would share their experience. So I do not know if you want to add something, either Eric or René, or was it clear for you?
Yeah, just to thanks for the invitation and the possibility to talk here. Also, the audience, thanks for your participation, for your questions, and also the good feedback which you already gave.
Yeah, thank you very much for having us.
Okay, so I will end the broadcast now, and I will also thank you to the audience of this presentation, and once again, one final time, thank you both René and Eric. Okay, see you.
See you.
Bye.
Thanks.
Thank you. Have a nice day. Bye.
Have a nice day too.